Okay, thank you. All right, so today we are going to touch on 1.3 applications of quadratic functions. This question now the question says that we have a projectile launched from a catapult. This is a catapult. Okay, and it's to smash a structure at the fort here. All right, so let's say there's a fort. Okay, we are going to smash something over here. So the projectile is given by this function. So we will have a y-axis of h and the x-axis of x. So once we project the object over, it will go in this motion, right? So it will go up and come down. However, it does not start from zero. The height does not start from zero. Okay, later we will see why. Don't know. Okay, now first part of the questions asks us, find the height of the projectile when it first left the catapult. Find the height when it first left the catapult. When it first left the catapult, what is equals to 0 at the very initial start? Okay, so at the initial, the distance from the catapult is 0. The distance from the catapult, so x is 0. Now in other examples, when it first left the catapult, it also means the words initial. Initially, what was the height? And also another word that we use is initially means time equals to 0. Now in this case, there's no t, right? So instead of letting t be 0, we let x be 0 because at the initial part, it has not left the catapult. So the horizontal distance from the catapult is 0. So at the beginning, we also learned about function. So this is the function negative 1 over 2500 x squared plus 22 over 25x plus 3. So we want to sub in what value of x? We want to sub in the value 0. So I will have this multiplied by 0 squared plus 2 over 25 multiplied by 0 plus 3. So what was my initial height? H is 3. Not x is 3, h is 3. Okay, exam will ask you also, what does this number mean? Okay, can someone try to share with us, what does h equals to 3 mean? What does it mean? Okay, think about this. Yes, the height of the catapult is 3 meters. That means initially, the height from here to here is 3 meters. Initially, the object at the catapult is at 3 meters high. The question is find the greatest height. Can we rephrase this question? Find the greatest height of the projectile. You all get it? To find the greatest height, you are finding the turning point, the maximum. Very good. So we have the maximum point. Now, which part of the lessons from 1.1 and 1.2 you learn about maximum point? 1.1. Okay, the part on completing the square, right? There are two ways to solve this. Okay, the first way is method 1, we complete the square. And from completed the square vertex form, straight away we can get the maximum point. The second way is we want to find the x values and we find the midpoint. After we find this x value, we will submit into the equation. So the thing now is, which is more tedious? The x1 and x2 is found using the quadratic formula, negative b plus minus square root b squared minus 4ac over 2a. So these are found using the formula. After you found the two x's, you find the midpoint, and that will give you the x. Once you have this x and you put in here, They'll give you your y, which is your h in this case. So method 1 or method 2, which one is easier? Okay, let's complete the square. Take out negative 1 over 2500, so that we are left with x squared minus, okay, this divided by this. We will have this divided by this, you get negative 200x. So we will complete the square for these two terms, plus a 3. Okay? So 200. So let's complete the square. Okay, recap. Completing the square, half dx and put in brackets. Subtract the square of that number there. That's how we complete the square. So we have completed the square. Okay, we are now going to expand this into the brackets. So some of us make mistake here. Actually, we forgot to expand this during your homework. And we will have negative 1 over 2500 x minus 100 square. This times this is 4. Plus 4 plus 3. Okay, and we have done it. So what is the maximum now? The maximum is 107. So do we want the 100 or do we want the 7? We know that the answer is either 100 or 7. Now 100 is actually your x. So the 7 is your h. That's the turning point, right? 107 is the turning point. But the question asks for the maximum height. So this is the one that we want. The question is, now I have a defense structure here. Okay, I have a defense structure. And the question is whether my catapult will hit this structure. Whether we hit the structure. So the structure is 150 meters away. So from here to here, it is 150 meters away. The structure is 5 meters above the ground. Will I hit it? So how do you do that? You need to sub in a value. So what value do I sub in? 150 or 5? Yes, I can either substitute this or this. But which one is easier? 150, is it your x or h? X. This is the 150 meter away. You see, this is the 150. So your 150, you must write this down that it is your x. What about your 5 meter? It is your h. So the question is, which is easier to sub in? I should be easier to sub in the x. So when I sub in the x, I want to see what type of height I have. That means when I sub in the x, I know my projectile fly how high. Alright, so let's sub in the x, which is 150. So I'll sub in 150. That will give us 150 square. Okay, this 2 should be 2 over 25. So yes, our height is 6. Very good. So will we hit the structure or not? I fly the projectile 150 meters away, it will be at 6 meters. My boulder will be at 6 meters. Yeah, the boulder will be at 6 meters, right? So this funny boulder will be at 6 meters. Okay, so that's what we call in army the bobo shooter. Shoo. So answer is, okay, it will miss. Okay, it will miss the structure. And the best way to answer a maths question like this is tell the examiner you will miss the structure by how much? By 1 meter high. Okay? Yes, the boulder, the projectile will be 1 meter above. Yeah, but it will go down on the other side. It will not like go down because it will still travel in the projectile motion. It will still travel in this projectile motion. So after this, it will go down, but it will still go down in the N shape. it will still go down in an N shape. So you will not hit the structure. Okay, can we stop the video? Thank you. Thank you.